Hey, what's up? I am Alf. Great to meet you. A little bit about myself. Welcome to the first ever Workloft live show, by the way. Great to be here on this YouTube channel. This is the first of many live shows. So good to be here talking about all things AI. So a little bit of context about me. Alfred, Alf, whatever you want to call me. I've spent the best part of 2 decades in the tech space at places like IBM and Vimeo. And a little while back, I became something I genuinely didn't see coming. An agentic builder, an AI agentic builder. But here's the twist. I don't really write code, never really been able to do that. I direct agents that do. This is the current setup that I have. I'm going to get into it today around my particular setup, but I direct agents to do a number of things for me. This channel is for you if you're thinking about getting into agentic building, and I'm pointing it squarely at the UK, Ireland, and the EU, because most of what's out there assumes you live in San Francisco or you're in the States, and you might be here, but if you're a fan of the channel, I suspect you're probably within the EU/UKI region. As you all know, the rules are very different over here. The constraints are different, and that turns out to matter a lot when working with these tools. My setup is deliberately small. I own 1 server and I run 8 AI agents, orchestrated through Claude Code. No team, no big cloud platform, no SaaS sprawl. 1 human, 8 agents, 1 machine, and you'll see the whole thing running live before the end of this live show. If you get something out of this, give the video a like and subscribe if you fancy more of it. All of my work can be found on my Workloft website, which looks like this on screen. Workloft.ai is where I publish all of my agentic work. So feel free to go and check that out if you would like. So we're going to get into a few stories this week, and they all point at the same thing. So let's go. Quick one to open. This week the story that's going around was that an AI agent went rogue on Fedora and trashed their bug tracker. Chaos. The machines are coming, shit. But that's not actually what happened, and the real version matters a lot more if you build with agents. So here's what actually went down. Someone got hold of a real maintainer's login, a trusted contributor, and they pointed an AI agent at it. The agent reassigned bugs, closed issues with comments that looked right and were actually wrong, and then it opened a pull request that got merged into Anaconda, the installer that puts Fedora and Red Hat on millions of machines. So forget rogue AI, forget Skynet. This is a stolen identity with an agent bolted on. And here's why that should land for you. We spend all of our time securing the model, prompt injection, guardrails, jailbreaks. The model was never the weak point here, the login was. An agent runs under a credential, and on a project like Fedora, that credential carries something you can't buy. Trust. A known contributor's pull request gets a faster, softer review. And the attacker didn't beat code review, he borrowed a reputation it was leaning on. So the main takeaway is this. The moment you give an agent a login, that login is a target worth stealing for someone out there because it scales the attacker. Treat agent credentials like the crown jewels, not config. and keep a human on anything that merges into something that other people install. Number 2, the next story we're covering today. There is a paper that's doing the rounds called Token Pilot, and the headline everyone grabbed is the number: up to 87% cheaper to run your agents. 87% cheaper, lovely. Everyone quotes it and scrolls on. Now here's the bit that nobody's saying out loud. Most context tricks save money by rewriting the prompt as they go, pruning it, evicting bits, shuffling it around. Token Pilot's whole move is to stop doing that. Keep the front of the context stable and only let things drop on a slow, deliberate schedule. Cheaper, yes, but a stable prompt is also a prompt you can replay. And that's the real prize. So why does this matter to builders, to a builder who's using this stuff? So put an agent near a customer record or a casework file, anything regulated, and the question you'll get asked is dead simple. What did the system actually have in front of it when it made that decision? If your cost-saving trick has been quietly rewriting the context, your honest answer is, I can't fully reconstruct that. And that's not a cost line. That is a gaping hole in your audit story. So the reframe, my friends. Cache continuity isn't a discount, it's whether your agent's decisions are reproducible after the fact. And that's the perfect cue to stop talking and show you what running this properly actually looks like. So, this isn't theory. We live in reality here at Workloft. And what I'm going to do is, I'm going to show you exactly what my setup looks like. Once I find the scene, here we go. Sensational. Let's get that music playing again, shall we? So what you can see on screen here, this is a terminal window. And as I said, this is not theory for me. This is actually real things that are happening. So I run 8 agents in production on my own box, on my own. And I've made this before the live show tonight. I've made this command, show fleet. And here's the whole operation. So here is the 8 agent roster. That's the team. You'll see in the top left there, the names of the different agents that I use. We've got Bob, who builds and ships. Bob's basically my orchestrator, my main guy, my MD. Named him after Bob Dylan. I don't think Bob Dylan would like that very much, would he? Larry does browser work. He runs OpenClaw. Walt does the bulk grunt work. Should I say Larry, his harness is OpenClaw. I think he's on Gemini. Walt does the bulk grunt work. Maggie runs outbound. Gary holds the to-do list. Ruby routes the models. Kit's my day job agent, kept totally separate. And Vera's a panel of judges that grades the others. 8 agents, 1 human, me. And these aren't frozen. I'm constantly changing them. We're constantly updating them, iterating on the daily. Vera, for example, this morning I gave her a new trick. She used to just vote ship or kill. So we would bring some ideas to Vera. She would choose whether or not to build them or kill them. 3 judges, majority wins. That's what Vera is. Useful, very useful. But it bins the interesting bit. So now, instead of one fused answer, she hands back a map where the 3 judges disagreed, and the good part, the risks none of them raised, I ran it on a real call for the product I build, how to wall off each other's council data, and it surfaced a hybrid option all 3 judges had missed. A single confident answer hides exactly the thing you needed to see. That shipped today. Very, very exciting things. Next up, we've got provenance. You'll see towards the second section. So this is where every action is logged, costed before it happens. This is the bit that ties straight back to Fedora, the article we mentioned earlier. Every single thing these agents do is logged before it happens. Append only. Append only. You can see it per agent, the calls, the failures, the cost. 1,000 actions in the last day. Total spend under £1. Let me say that again. 1,000 actions in the last 24 hours. Total spend under £1. So if one of my credentials ever got compromised like Fedora's in that article, I can tell you exactly what touched what and roll it back. Recent actions, append only ledger. Here's the raw ledger. So timestamp, which agent, what it did, what it cost, how long it took. And this is the important column, what triggered it. Not an agent did something, a named action with a cause on the record. Boom, lovely. Spend by tool, costed per call. Every call is costed per model. I can see exactly where the money goes. It's not vanity. If you can't cost an agent per action, you can't run a business on one. It really is as simple as that. You need to be able to know exactly where the cost is going, where token inference is taking place. Next up, we got least privilege, credentials under management. This is the Fedora lesson made real. So 16 credentials under management, number shown on this screen, 0. Every one scoped, none of them are God key. And you're watching me demo this live without a single secret hitting the screen because the tool physically won't print them. That's the discipline. An agent's identity is a target now. Treat it like one. Next up, routing. Model picked per task with failover, and this is Ruby on the top. You'll see Ruby is the name of the agent. This is the token pilot half. I'm not locked to one model. Ruby picks the right model per task and fails over across providers. Anthropic, Google, OpenRouter, local. Cheap models for cheap jobs, the big ones only when it's worth it. Hello, Fable. Hello, God, I miss Fable. Those were some good days. The substrate decides, not the vendor. It really is as simple as that. My main guy, Bob, he puts it over to Ruby. Ruby decides how the task should be routed. And when it's worth it, isn't a vibe, when it's worth it, it's not a vibe. I put a number on it this morning. There's a pitch doing the rounds that you wrap a cheap model in a clever harness, sample it a few times, take the majority answer, and you're as good as a frontier model for pennies. So today I built a task with a right answer and measured it. The harness does the work. It dragged the cheap model up 5 points to match the big one, the big frontier model, but it costs 3 times as much to get there. And the frontier model, run once, beat it on price anyway. So the rule the routing's built on holds. A harness can rescue a cheap model, but it doesn't make it free. Sometimes the expensive model is the cheap option. And that is a build from today too. Numbers are on the site, as you can see. So as you can see on the very bottom there, we've got a lovely little way to sum this all up. And it is, the model is never the risk surface. The substrate is identity, provenance, context. That's it. Get those 3 right. Who the agent is, whether you can prove what it did and what it had in front of it, and the model can be as clever or as daft as you like. Don't know why I'm doing this. It's politics. So both stories are written up on the Workloft website. I showed it earlier. If you are interested in taking a look, let's go back to our other screen. Just doing things on the fly here. Back here we are. You can go to workloft.ai and you can go to labs. This is my research arm. Scroll down and you'll see labs news here. And here is all of the news articles that have come out. If you want to take a look at my builds, you can do that in a couple of ways. You can go to Workloft ships, which is this section here. Ships log. These are all the builds that we've done. Over 60 builds now. Over 60 builds. So what we're doing here is we're scraping the latest and greatest research across the internet, using the agents to find the best research. We are implementing the stuff that makes us better, that makes us more powerful, that makes us more secure. And we are writing about it. We publish across X, LinkedIn, Blue Sky, Mastodon, to name a few. And that is the loop. We call it the Workloft loop. So if you want to take a look at any of the stories or take a look at anything that we're building, you can also go to my my GitHub page. I've framed it as open source, and here are all the builds on GitHub. So if you are interested to do any of the things that I'm doing to make yourselves more powerful, more secure, faster, then I am publishing all of the work. It is free. There is an API key. So what you can do is, if you go to Workloft, and we'll go back to Workloft Labs, scroll down to the bottom, read via API. Get a free key. So daily research picks your agent can actually call. Here is the key if you also want to get involved in some of the research that we are doing at Workloft. I'll leave you with the question that I'm sitting on this evening. Where is the substrate gap in your stack, friends? Because that's where it goes wrong first. See you next time. Peace.